Hi everybody, and welcome to this video on energy calculations. You will need a calculator and perhaps a scrap piece of paper for this lesson. Okay, so for grade 10, we don't do a ton of energy calculations, but we do have two different types of energy that we can calculate. So the first one is gravitational potential energy. You don't have to write this equation down. It's actually in your workbook in section 3.1, or it's also in your textbook in section 3.1. But I've written out here for you so we can talk about it. So gravitational potential energy, you remember, is the energy that an object has because of its height or its position. So the equation for this is E for energy with little g for gravitational potential energy is equal to mg delta h. What do those mean? So m is for mass. We measure mass in kilograms. That's the SI unit or standard international unit that all scientists use for mass is grams or kilograms. In this case, kilograms is what we'll use for our calculation. G stands for gravity. It's the acceleration due to gravity. So how much speed something picks up as it's falling, right? When you first drop something, it'll fall slowly, but it'll pick up speed or accelerate as it falls. And actually on Earth, the acceleration due to gravity is 9.8 meters per second squared. It would be lower on the moon. It would be higher on larger planets like Neptune. And then delta H, the Greek letter delta means a change. So delta H is, in this case, a change in height, and we measure that in meters. So the energy due to gravity is the mass times the acceleration due to gravity times the change in height. We can also calculate the mechanical potential energy. So this is found with the formula EK for kinetic energy. Oh, this should say kinetic. Yikes. And it is equal to the 1/2 the mass, so same as before, times the velocity squared. Velocity is similar to speed. It is how fast something is moving. The only difference is that velocity includes a direction, which you'll see doesn't really matter for these calculations. And my patented foolproof way of solving physics problems is called the less stress method. So LESS, they all stand for something. L is for list. You list the quantities you're given in the question. E is the equation. You should write the equation you're going to use. S is substitute the numbers you know into the equation. And second S is solve using your calculator. So we're going to go through some example problems right now. So there are some sample problems in your textbook on page 213 and 214, but we're just going to do some together. So a 54 kilogram skier, including equipment, stands at the top of a Black Diamond ski run. For those of you who don't know, that's the hardest kind of ski run. The vertical distance to the bottom of the run is 420 meters. What is the gravitational potential energy of the skier relative to the bottom of the ski run? So sometimes in physics, I find it's really helpful to just draw a little picture. So here's my mountain slope. Okay, here's my skier at the top, looking very brave and ready to ski down that mountain. The skier weighs 54 kilograms. And the vertical distance, so from where the skier is to the bottom of the hill, is 420 meters. Okay, so let's go back to the less stress method. The first step is to list your known quantities. So you're going to go into your equation and you're going to find the different numbers or quantities that there are. And so when you write it out, try and identify what it is. So 54 kilogram skier, that's their mass. So M equals 54 kilograms. Okay, and then the vertical distance from the top of the run to the bottom is 420 meters. We also know that we're looking for gravitational potential energy, so I can look at my equation to give me a hint. The vertical distance is the change in height. So delta H equals 420 meters. Great, okay, that's the first step. The second step is write the equation. So because it's gravitational potential energy, we're going to write EG equals mg delta H. Great. Finish that step. Next is substitute. So we're going to take the numbers that we know and put them into the equation. So EG is, so mass is 54 kilograms times the gravitational potential, or sorry, the acceleration due to gravity is 9.8 meters per second squared times, oh, you can use a dot for times. Have you seen that in math class before? Delta H is 420 meters. Okay, now you can go ahead and put that in your calculator, which I will do right now. Oops. Okay, so what I got was 2, 6, 4. Okay, so 222,264. What are my units? So for energy, for this calculation, we measure energy in joules. So 222,264 joules. That's a lot of energy. I guess they're quite high up. Okay, that's the first question done. Let's try another one. A satellite has a mass of 689 kilograms and travels at a speed of 27,000 kilometers per hour. And hopefully they've given us meters per second, so we don't have to convert it. You have to use the units that I showed you on the other sheet. How much mechanical kinetic energy does the satellite have? Okay, so first step, L of the less stress method stands for list. So let's look at all of the different numbers we have here. We have 689, and then we have this meters per second as the velocity. So a satellite has a mass of 689, so M equals 689 kilograms, and it travels at this velocity, 7,500 meters per second. Okay, that's what we've got. So next step is E, write the equation. We're using this equation. EK equals 1/2 mv squared. Okay. Next step is to substitute the numbers that you know. So we're going to put this m in right here. So EK equals 1/2 times 689. This is another way you can do it. Oh, I should put the units in. It's just good to double check that you're using the right ones. Times 7,500 squared, oops, meters per second. Okay, I'm going to type that into my calculator. You can put in 0.5 instead of 1/2 if it's hard to do fractions on your calculator. actually you should make sure that you put in the squared. If your calculator does BEDMAS, you're fine. And usually if you can see a line on your calculator showing you your equation, that's fine. But if it doesn't, you're going to have to do this one squared first. Remember, in BEDMAS, exponents comes before multiplication. Okay, so I've got a huge number here. 1, 9, 3, 7, 8, 1, 2, 5, 0, 0, 0. I've written it very messily also, joules. For grade 10 science, you can leave the answer like that, but I'm going to show you a trick for writing big numbers that's called scientific notation. What you do in scientific notation is you look at the first 3 digits, and then you put a decimal between the first 2, and then you round this one. So 7 makes that 3 round up. And then you write times 10 to the, and imagine that this number had a decimal here. You got to move that over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots to get it between the 1 and the 9. So you write times 10 to the 10 joules. That's scientific notation. If you don't want to do that, if you just want to do this, that is okay. This is something you'll need for Physics 11. Okay, let's do another question. This kind is a little bit different because instead of looking for the energy, you're looking for the mass. So a bowling ball is rolling down the lane at 2.8 meters per second. If it has the mechanical kinetic energy of 25.5 joules, what is its mass? Okay, so mass is what we're looking for. Sometimes I like to write it with a question mark to remind myself. All right, so we have 2.8 meters per second. That's a velocity. We have the mechanical kinetic energy of 25.5 joules. So that's EK equals 25.5 joules. Okay, so step 1 was list. Step 2, write the equation. EK equals 1/2 mv squared. Step 3 is substitute. So I know 25.5 equals 1/2, and then my mass is 2.8. Oh, sorry, that's my velocity. I'm trying to find out mass. I hope you all screamed at your computer screen. Okay, the velocity is 25. Nope, 2.8 squared. Okay, so now we got to rearrange this just like in math class. Woohoo! So first I'm going to do the operations here on this side. So I've got 1/2 times 2.8 squared. So I'm going to grab my calculator. I'm sorry you can't see my calculator. I'm using my computer because my phone is recording this. So I've got 1/2 times 2.8 squared. Again, if you're using a simple calculator, it won't do BEDMAS, so you should make sure put in 2.8 squared first. Okay, so now I have 1/2 times 2.8 squared is 3.92 m. I haven't put my units in this time, I forgot. That's okay, as long as I remember them at the end. Okay, so now you know what to do for math class. You have to divide both sides by 3.92. These cancel out, so you're left with m on this side, and then 25.5 divided by 3.92 is 6.51. I'm going to round it to 2 decimal places. That's enough. Okay, and mass, the unit, let's look back at our sheet. Mass is always in kilograms. So the mass of our bowling ball is 6.51 kilograms. All right. If you feel ready, you can stop the video here and go do the practice in the workbook. If you feel like you want one more example, here is one more example. So a person who has a mass of 65 kilograms goes on the Sky Tower ride at an amusement park. The ride is simply a free fall from the top of a tower into a net below. If the person reaches a final velocity of 24.6 meters per second just before hitting the net, from what height did the rider drop? Okay, this is a tricky one. I'm going to show you how to do it. So here's basically there's a tower and there's a net at the bottom, and a person is going to fall off the tower into the net. That's what I get from this question. That doesn't sound like much of a ride. Anyways, so first step is list. So we've got a mass of 65 kilograms. And the ride is a free fall. If the person reaches a final velocity, that means the speed that they're going at right before they hit the bottom, the net. So 24.6 meters per second. From what height did the rider drop? Now, the reason I said this was a tricky question is because in order to calculate the height, you need the mass and the gravitational potential energy, and you don't have it. What you are given is the velocity. So remember in our skate park, when a person is at the very top, or an object is at the very top of a tall thing, they have a lot of potential energy, and right when they hit the bottom, all of that potential energy is transferred into kinetic energy. So what we can do is calculate the kinetic energy that the person has right at the bottom and use that to calculate how much potential, use that as the potential energy they had at the top to calculate the height. So I'll show you what I mean. So first thing we're going to do is calculate the mechanical kinetic energy. So the equation for that is EK equals 1/2 mv squared. And my EK is going to equal, we're substituting now, 1/2 the mass, 65 kilograms, times 24.6 meters per second squared. Okay, that's a pretty straightforward one. You're just going to put that in your calculator. 0.5 times 65 times 24.6 squared. Okay, and I got 196,677 joules. Okay, so right at the bottom of this free fall, the person has this many joules, 196,677 joules. That's how much potential energy they must have had when they were standing at the top. So now I also have the information of their potential energy, 196,677 joules. So now I can use this equation, the gravitational potential energy, to find out the height, which is what I'm looking for. So my gravitational potential energy equation is mg delta h. Okay, so we have didn't leave myself enough room. We have the gravitational potential energy, we have the mass, we have the acceleration due to gravity. We can assume this is happening on Earth, but what we don't have is the delta H. Okay, so fire up your calculator. 65 times 9.8. I got 637. I hope you did too. Delta H. And 196,677 over here. Divide both sides, 637, divide 637. Those cancel. So my delta H is 308.7 0.76. 2 decimal places is fine. And this is height, so that is meters. So from what height did the rider drop? 308.76 meters. Phew, that was a toughie. We had to do 2 different calculations, but I hope that helped. Go ahead and give those workbook pages a try. Let me know if you have any questions. Good luck. Thanks for watching.